Hello everyone, Mr. Science Mover here, and today is the long-awaited tutorial on how to change models in Back 4 Blood. Now, changing models in Back 4 Blood is currently extremely difficult because of how the Unreal Engine that Turtle Rock uses packs up these models. There's a bunch of extra data that is very difficult to export in the same way as the textures that I've done previously. So this is my custom way of editing models, and I plan to develop it further and make more tutorials on that in the future, but I wanted to get this out as soon as possible for people who feel like they have the proper expertise to do such a thing. I will say ahead of time that this is going to require some 3D modeling experience. Um, what I'm doing is I'm using Blender to edit the models. I believe you can also do it in Maya or 3ds Max. We're going to mostly be editing raw vertices in this tutorial. So in the future, I'll go through certain plugins I've found or ways to streamline the process, but right now this is the easiest way that I've found to do it. So first we're going to open up UModel to extract the model that we want to change. So let's go into our extracted content and let's edit a character, edit a cleaner, and we'll pick Holly for this. So we can open this folder. So here we have our meshes. The head, legs, and torsos are the custom built skins where you can pick the head, torso, and legs of your skin, and the elites are the ones that come pre-built. So for this, let's open Elite 0. We'll pick 4.26, and we have our base Holly. So one thing you'll notice is that we have this list here of data stored in this file. And the most important one to us right now is that there are 5 LODs, which stands for level of detail. So level of detail 0 is the highest definition model. So if we zoom in really close on this, we can see how textured and modeled this model really is very thoroughly. That's LOD 0, and you can see it has almost 100,000 triangles. But if we pan over to increasing LODs, you can see the level of detail actually decreases to the point where if you get very far away from a model, this is what Holly is actually being rendered as. It doesn't look pretty, but it doesn't have to look pretty if you're seeing her at this size. So that's what the level of details are for. They swap in and out to improve performance when you get far away from a model so that it takes up less space on your screen. So because it's taking up fewer pixels, you don't need to render as many polys. So you can see this one only has 6,000 triangles. The problem for us as modders is that we now have to change all 5 of these LODs in order for the mod to work seamlessly. So what we're going to do is we're going to go to Tools, we're going to export the current object, make sure that Export LODs is checked so that we get all of those models, and we're going to export to a folder that we know where it is. So we're going to create a new folder, we'll call it Exported Holly. I'm going to export there and hit OK. Now we can see UModel is exporting the model, but also all the textures with it. And now we can see we're done. So we're going to quit out of UModel. And what we have in our exported Holly folder is our 5 LODs. So this base is LOD 0, and then these 4 are the increasing levels of detail. So you can see they actually take up less space as you go on because the number of vertices and triangles is decreasing. So what we have to do from here is we have to open each of these and convert it to a file format that we can actually read. So in order to do that, we're going to open Blender, and we're going to have to use this plugin right here called import PSK. There is a version that comes with Blender, but do not use that one. I will link the proper PSK plugin in the description. And it'll give you two of these plugins. One is for Blender 2.7 and one is for Blender 2.8 and above. So I'm using 2.7 right now, so I'm using the 2.7 version. And you can import that under user preferences in add-ons at the top, and then we can install add-on from file. We'll navigate to that folder and click on that add-on. And then if we hit search, we'll search PSK, and you can see this is the one that you want to install. If you open up the different descriptions, this is the embedded one, I believe. But you can see that they have different authors to them. So you want to make sure that the one that you're using is the one that is, first of all, stored in app data. The other ones are stored under Blender Foundation because those come with Blender embedded. So you want to check this one. Mine's already checked because I've used it before. And then we'll hit Save User Settings so that it will persist when you reopen Blender in the future. So what that does is allows us to go to File, Import, and now we have two more options at the bottom, which is for skeleton mesh or animation. So we're going to go ahead and hit the skeleton mesh, and then we're going to go back to our exported Holly, and we're going to open level detail 0. And what that gives us is our Holly model. Now we can see here that there's actually a few things wrong with this mesh in that these normals here are flipped. And immediately you also see our skeleton here, which we are actually not going to need for this. So I'm going to go ahead and delete that. So one thing you'll notice about this model now that we've imported it is that if we look at the top right here, we can see we have the same number of triangles as before, almost 100,000, but we have much fewer vertices, almost a third of the number of vertices we had before. And the reason for that is that when Unreal packs up this model, it doesn't treat vertices the same as Blender does. So if we go into edit mode and we look at one of these vertices, we can see that this vertex, for example, is completely connected to this shirt right here. If I pull it out, it'll stretch the faces that's connected to it. But once this model is exported into Unreal, it actually treats this vertex as not connected to all of these faces necessarily. So what I've found is that in order for a vertex to be completely connected in Unreal, there's a specific setting that you have to set in Unreal that connects these two. And the settings that Turtle Rock exports with are very precise, and I haven't been able to figure them out myself. So what we're going to do is find a way around that, because that is extremely unreliable, basically. Because the algorithm is actually embedded in Unreal Engine itself. And so if we make any tiny change to a model, say we move this to something like this, it might just take this and interpret it as it might just interpret it in a different way. So for example, if we make it a steeper slope or a more shallow slope, or if we move it over closer to another vertex, it might say, well, if that's so close, then we can keep these intact, but not these. And basically, Unreal does whatever it does to optimize for gameplay. And in terms of what Turtle Rock has to do, it's really not relevant to them at all because they just hit the export button. But for what we have to do, we need that export to be the same as our export, which is very difficult. So what we're going to have to do actually is use the original U asset, which stores the exact data that Back 4 Blood uses for this model, and extract from it a model that maintains the vertex ordering. So I've developed a few tools to help with that, and I'm going to show you how to use them right now. So what I have here is a Python script that will let us extract an OBJ from the data that we find in the USet file. Now this does basically the same thing that UModel does, except for us it's very important that the vertices are stored in the same order. I've found that exporting from UModel doesn't ensure that. So I've written some code myself so that I can make sure that it's always in the same order. The reason that is that UModel is typically not for explicitly modding purposes. It's more for using models from the game in other situations where vertex ordering doesn't matter. But for us, and especially because we're not going to be changing skeletons just yet, it is very important that these are in the same order. So what we're going to have to do is open our original UXP file in HXD. So it's going to be this 3P Holly Elite 0 SKM. That's our model. And what we're going to have to do is, first we start with LOD 0. Fortunately, these are stored in order. So LOD 0 is first, and then 1, 2, 3, 4. They're all stored in this file. And what we're going to have to do is find where our vertices are stored. Now we can tell this based on the general structure of the data here. So it is a bit difficult to find what we're looking for and even to know what we're looking for. So here's an example from a different model that I've extracted, and it might not be so obvious how you're going to actually find this data, but you can see that in these columns we have, so right here we have a repeating 43, right here we have like 41s, 40s, we have another 41s, 43s, 43, 41. So those are the vertices, and the reason that I can say that they're usually in that format is because of how the models are sized in the software that Turtle Rock uses to model these things. So the 41s and 43s are basically just telling us positions of the vertices in the real world space. So we're going to look for the first instance of that. I'm actually going to use the bar on the side because this file is extremely big. And what we're going to do is look for a nice chunk where we can see something that looks like that. All right, so now we can see I've scrolled down to the point where I found, basically looking down the first column, we have 41, 40s, bunch of 41s and 40s. Then column 5 is the same, column 8 is the same, and column 12 is the same. And the reason for that is because floats are 4 bytes long. So what that does is each of these columns corresponds to the first byte of a float. So we can say this is a float, this is another float, this is another float. And these are all floats corresponding to the positions of vertices. So what we're going to do is we're going to have to scroll all the way up to the top of where this actually starts. And this part is kind of the hard part because we don't know where it ends. All right, so once we hit this, we've gone too far. So we're going to scroll down a bit. And now we're back right at the point in between our faces, which is what's up here, and our vertices, which is what's down here. So right after this number telling us how many vertices there are, we're going to take all of the data that corresponds to vertices. So we can scroll until we see the bottom of that nice 41 chunk. So once we hit this pattern of 7 Fs, we've gone too far. So we're going to scroll back up and try to get a roundabout location. And then we'll just scroll down. So you can see we're still holding 41, 40, 43. And once we hit this nice line of zeros, we know that we're done. So what this is going to do is it's going to end right here. And you should have, it should end in a 0, 1, 0, 0. And what that is it's the chunk of the next bit here, which tells us actually the texture chords. Right now I'm not going to mess with any texture chords, but if we do eventually want to change the textures of the models that we're changing, that will be necessary. So that's for another video, but it will be hopefully coming in the future. So right now we're going to take all of this, we're going to copy this, and we're going to take our vertex data. Right now there's stuff in it, but we're going to delete that and we're going to paste this vertex data. And we can see actually it's kind of in the same format as before. We have all our 43s here, our 41s and 40s, and it's looking right. So we're going to save that for our vertex data. Then we're going to go ahead and open our face data. Now this face data is also from a different model, but you can see that there are a lot of zeros here. And the reason for that is because every 4 of these is a number corresponding to a vertex index. So this whole 0, 0, 0, 0, 0, 0, 0, 0 corresponds to vertex 0. And the triangles are formed in order. So we can say this is vertex 0, vertex 1, vertex 2. Those form one triangle. Vertex 3, 4, and 5 form another triangle. 6, 7, 8 form another triangle. And you can see they kind of go in order until you get to a certain point as you're scrolling down where you can see that the 3 in order kind of lose their ordering. So you can see here we have BA03 with B903 and then B803. And the reason for that is because the faces that are later on are using vertices that are previously defined. So it has to reference vertices that are already been numbered. So this whole file corresponds to all of the faces. This one model happened to have this many vertices. Ours is not going to have that many. But we can use this format to try and find the face data, which is actually right above the vertex data if you found that already. So we're going to go to the very top of our vertex data, which we've already selected. And once we're here, we can see that we have, again, this is our number of vertices. We're going to go back to right before here. So when we have this 0C here, the 0C0000, this is the start of this new vertex block. So right before it is where the face count ends. So we're going to then head up to the top of the faces. And once we get here, we're going to select all the way up until this last 0. So make sure that this last thing you select is 4 bytes of just 0, because that's vertex 0. And then we're going to copy all of that into our face data. And once that's in, we can hit save. And we can exit out of that. We can exit out of our HXT. Actually, we're going to need this later, so we'll just minimize it for now. And we'll head into this Python script. The one thing that may become an issue is our current faces are needing 4 bytes to be represented, but some smaller models, and specifically the smaller LODs, are going to only require 2 bytes. So I'll go through that later when I get to the lower LODs and how to change that to export those as well. So for now, we're going to run this script. And I'm going to run the script to generate a new OBJ for us. Might take a while. And once that's done, we'll have a nice output.obj right here that we can then import into Blender again. So we can go ahead and delete what we have before. And we're going to import our new OBJ, which is properly ordered. So once we open that, we're going to see it is lying on its side, which is actually necessary because that is how the original file is designated. The reason for that is likely due to differences in XYZ coordinates for Blender versus the modeling software that they use. But we do have to export in this format so that it translates back properly. So right now we have our OBJ and everything is in proper ordering. So we can go ahead and edit this in any way we want. What we're going to do first actually is I want to rotate this along X so that it is facing up. And we can undo that rotation later. So if we start to edit this model right now, there's one thing that you'll notice pretty quickly. So if we go into edit mode on this model and we select, say, vertices on the shirt, we can go ahead and change that pretty easily. But if we go and try to change a vertex on, say, the hat, we're going to find something pretty different. So what is actually happening here is that for whatever reason, the model that is used in game for Holly does not treat this one vertex as combined in this one spot. So we actually have 4 different vertices that are all located in the same exact world position. And that's why the original model that we had exported as a PSK did not show this number of vertices, because vertices like these were all contained in one vertex. So in order to actually be able to edit this model, we can go ahead and change things like this shirt in a meaningful way. We can scale it up, scale it down. We can warp it however we want to. But if we want to change something like the hat, we can't just mass select the entire thing because it's really divided into chunks. And it's a little hard to edit. In order to solve this issue, I've written 3 different scripts that solve this issue in this way. So we start with a model in an OBJ format that has properly indexed vertices. That's because we extracted it directly from our UAsset. Now, we want to edit that model in a meaningful way with our vertices connected. But if we merge those vertices in our original OBJ, it won't maintain the same topography and we won't be able to replace it. So what we have to do is take the vertices of our original OBJ and order them, number them, and then we're going to merge all the vertices that we can in that OBJ and export another OBJ. Then we're going to number all of those vertices and create a map between the vertices of the original OBJ and the vertices of the new OBJ based on where those vertices are. Remember that these vertices have the exact same position. So if we have 4 different vertices in the original OBJ that all have the same position, we're going to map all of those onto that new vertex in the new OBJ. Now, because we have a map of our original vertices to our new vertices, we can go ahead and change our new OBJ in a much easier way than we could the original OBJ. Then, once we're finished editing our new OBJ, we can export that OBJ, take all of those vertices, which are still in the same order, and take the locations of the vertices and replace the locations of the vertices in the original OBJ that those vertices are mapped to. So then we'll have a model with all of the original topology and all of the original vertices, but with the newly edited vertex locations. And if all of that was too confusing for you, then it's okay because I'm going to go step by step. So our step 1 is actually going to be to merge our OBJ in the first place. So remember again that this starts off on its side, so we're going to rotate it back to the way we found it. And then we're going to select all and merge all of our vertices by removing doubles. And we can see it says removed about 60,000 vertices. That's almost half the file. So now we're down to only 61,000 vertices, which is a crazy amount to be removing. So now that we have our merged, we can see selecting something like, say, the hat is a lot easier. And we could just select that whole thing and move it however we want. So you can see how that would be appealing for editing our model. So we're going to now export this as an OBJ. Our settings here are actually very important. So we're going to uncheck apply modifiers, include edges, basically everything here we're going to uncheck. We can keep objects as OBJ objects, but that should be the only one that we export. And we're going to export that as output merged. So what we're going to do first is isolate the vertices from both the output and output merged OBJs. So we want to have the vertices in order, but basically we can just use the line of the vertex as its index in the map. So as long as we remove all of the faces from the file and the header, we'll be fine. So we're going to run this script. We're going to get 2 new files, vertices output and vertices output merged. So if we open this, we can see that it is just a file of all of our vertices in order. So we're going to use the line number as the index of that vertex for our map. And if we open this one, we can see the same thing here. So what we're going to do next is map our original vertices to our new merged vertices by running this map indices Python script. And it might take a little bit, but once it's done, then we will have our map. So now that that's done, we can open our vertex map.txt and we can see some of these vertices map to themselves. So like vertex 0 maps to vertex 0 in the new one. But then we can look, say vertex number 16 in the original was a duplicate of vertex number 6. So it just simplifies that for us. So now we can go back to Blender and make sure that we're working on our merged OBJ. So now we can take this OBJ and edit our vertices in this OBJ. So let's rotate by -90. We have our nice model right here, nice connected hat. Let's say we want to change the rotation of this hat. So we're going to mask select all these vertices and we'll rotate it, say on the Z, rotate along the Y. And we'll give her a front-facing cap. Now, sometimes what you may find is that there are vertices that get in your way or in the wrong spots, and you just don't want them anymore. It might be very tempting to delete them, but if you do that, then it'll mess up the topology of the mesh. So what we really have to do is, if there's a vertex that we don't like, say this piece of hair sticking out of the hat, we'll just grab it and drag it back in so that we can't see it anymore. And we'll just do that for all of these until we get a hat that's looking nice. So now that I've moved the hat, you can see there's still a little bit of trouble in the back with the hair not being completely covered, since in the original mesh, this was hidden by the bill of the hat, so it wasn't necessary to fill out. So what I'm going to do right here is I'm going to attempt to lengthen all of these hair strands, and we'll see how it turns out. Alright, so I'm admittedly not the best hairstylist, but I think we've got something cool going on here. I put her ponytail through the slot in her hat, and it's a bit messy underneath, but we'll ignore that for now. So now that we have our model, we're going to first rotate it back 90 degrees so all the vertices are in the same spots. We're going to save this so that I have it for later. We're going to save it in our exported Holly. We'll save it right here. And this will be our output edited. And then we're going to export as an OBJ like we did before. Make sure nothing is checked except for that one. And we're going to name this output edited. So what we're going to do now is run this script called copy positions. And what that does is it will take our vertex map and apply it to our new edited output to insert all of those vertex positions back into our original OBJ in their respective vertices. So we're going to run this, and then we're going to get a new file called output new. And what that is it's the original OBJ with the original topography, but with the new edited vertex locations. So if we go into Blender, we delete what we have right now, and we re-import our output new, we can see that this is what it looks like. So if we take a look at the hat, we can see that it has all the stuff we've edited, but most notably is if we try to select the hat like we did before, we can't select it all at once because it has the original topography, which was the whole reason for making a new merged OBJ in the first place, because this is a whole pain to edit. So now that we have our new OBJ, we can run our create UAsset model data from OBJ script, which does exactly what it says. So when we run the script, we're going to get these two files, output F and output V, and we're going to open this up, and it's going to look somewhat familiar. So we're going to have a bunch of zeros, and then 1, 2, 3, 4, 5. So if you look at this, this is actually the same format as our original face data. Now, because we didn't actually change any faces, we don't really need this data right now, but you can see it's identical. What we really need is, because we move the vertices, is we need our output underscore V, and we can compare that to our vertex data. Now, if we put these two side by side, we can see that it starts in the same way, 86EA0341, and so on. But this new output V includes all of our changed vertex locations. So what we can now do is we're going to go back, way back into HXD, where we took this data from, and we're going to head to the top of the vertices. And once we're here, we're going to see this exact line, and we're going to take all of this, copy it, and right here, we're going to hit paste right. And if you've done everything right, you should see this again, 0100 at the very end of that vertex block. So now we have our modded Holly skin. So we can go ahead and save this. Because I'm using the original extracted version, I'm going to go ahead and actually save it in its own mod folder. So now that it has its own mod folder and it's in the correct location, we're just going to go ahead and save that. And everything should turn black, which means that it's saved. So now our mod is actually complete, but the problem is that we've only changed level of detail 1, or the first level of detail, which is level of detail 0. So as I said earlier, level of detail 0 is the highest level of detail. But for characters like Holly, they're going to have 5 levels of detail. So you're going to have to do this 5 times, once for each level of detail. So you can see we have our 41s here. Below that, we'll see like a 7F column. This is where all of the normals, no, this is where the texture coordinates are stored. So this tells the vertices where to look in their texture to get the color that they should be painted. Then after that, we'll have a jumble of stuff, which is likely for bones and all of that sorts of things. And then there's a whole lot of empty space and a bunch of F's for some reason. But the next time we see anything meaningful, this looks like faces to me, it's going to be level of detail 1. Right, it looks like it's right here. So you can see it's like 4 zeros, 4 3s, C1s. That's what I'm looking for when I'm looking in this. It's really something that you kind of just have to get the hang of. I don't know how UAssets store all of this data. So that's the thing, is because we're editing this like manually, it's extremely difficult to know what to change. So we're going to scroll all the way up to our faces, and then I believe this level of detail is where we'll have that minor change. So here we are again at the top of the vertex data. So that's all of this down here, starting right here, going straight down. But if you notice, our number of vertices only takes up 2 bytes instead of 3 where it was before. So what that means is that for the faces, each face is only going to take up 6 bytes total, because each vertex number is only going to take up 2 bytes. So it can actually store level detail 1 in a lot less data, because the faces only need 2 bytes per vertex instead of 4 for the level of detail 0. So I'll upload a separate script for that, for taking this data and converting it. It's a very minor change, but it's very important, because otherwise you're going to have basically half as many faces as you're supposed to, and half the faces are just not going to exist, and half the faces are gonna be all mangled. So you're going to want to use that script instead for levels of detail like this. I don't think there are going to be any models in the game that only use 1 byte. Theoretically, it's possible, but that would mean it would have to have fewer than 256 vertices, which I guess is possible. But if you find one, let me know. The change is actually pretty simple, and I can upload a script for that if anyone needs. So this is LOD1. You can see the 7Fs. We can scroll down a bit and we'll find LOD2. We can scroll down a bit more. And this looks like LOD3 here. Scroll down some more. We've got another one. See, I'm just looking here for the 41, 42, C0. And then the last one at the bottom. So right now I'm only going to do LOD0 for the sake of this video, but if you wanted to have a mod that worked in all situations under all graphics settings, you'd have to change all 5 of those models. So I'm going to quit out of HXD, we'll close this, and now that we have our full Holly mod, I'm just going to go ahead and pack that up in the same way that we've always had. So we'll open up Unreal Pack in the window. We'll take our Holly Hat mod to Unreal Pack without compression. And we'll take that and replace the ending. And now we have our completed mod. So I'm going to drop that into our folder. We'll steal a signature. Oops. And let's go launch the game. Okay, so now we've got our game started. We can go ahead and start offline. Although this mod will work online since it's just a model swap. We're gonna have cleaners, and we'll check out Holly. So you'll see actually, it's not registering right now because I have my graphics setting very low. So this is actually LOD2 that you're seeing. So because we've only changed LOD0, I'm gonna have to go into my settings and actually make that visible. So I'm on quality low. So let's put on quality ultra, and then we'll be able to see it. There we go. Look at that. Beautiful. So yeah, basically, if you wanted to, you could do this with all of the other LODs as well, but make sure whenever you're changing things, you change it on every single LOD. Otherwise, you're gonna not see it if you have your graphics setting too low. So that's it for this video. Hopefully, it's comprehensive. And if you guys have any questions, let me know in the comments or in our Discord. We have a dedicated Back for Blood modding channel now for people to just share what they're working on, ask for help, and any of that sort of stuff. So I'll see you guys in the future when I make some more progress. Thanks for watching, and hope you guys make some cool stuff. See ya.